Hi, I'm John Free, and I'm an independent technology analyst. I focus primarily on networks and networking. Today, we're going to talk about home networks. And home networks can range from the very simplest all the way up to the far more advanced, depending on the needs of the individual user. So we're going to talk about the different components and what those components can do for you. Now, before we get started, we need to talk about the different network functions that you'll have. First and foremost, you're going to need some type of external access, some way to connect to the internet, the broader world out there. That's typically done through a cable modem, a DSL modem. If you happen to have an ISP that's providing fiber for you, you would have something called an ONT. And these are all devices that the provider will give you, and that will allow you to connect to their network, and their network will then connect to the broader internet. Inside your house, you're going to need some device that can keep track of data requests, send data back and forth to the right places. This is called the router. You're going to need a way to have multiple wired clients like desktop computers or maybe television streaming devices be able to share data. So for wired connections, that's a network switch. Then you're going to need a way to provide access for wireless users, such as phones, tablets, maybe notebooks, and that would be a wireless access point. And then you're going to need some way to manage all of that, and that's where the console comes in. And this console could be very simple to simply manage a single router, or it could be a very complex system that looks over the entire network and all of the security and configuration and can let you track everything down to the most minute data. The connection to your internet provider is going to come from something called a cable modem. That tall black box on the left there is a cable modem. This is provided by my internet service provider, and it provides a connection back to them. Cable modem is a kind of a generic term. If you have a DSL provider, you would have a DSL modem. If you had a fiber provider, you would have something called an ONT. But all of these are generally provided by the company that you're getting your internet service from, and these will allow you some type of access back into their network. Some internet service providers will allow you to buy your own modem, and a lot of people ask me, is that a smart idea? Because, I can save money by doing that. But you have to keep in mind that if you buy your own modem, you're really now on the hook for doing all your own support. So if you feel comfortable doing your own support and you think you can do that troubleshooting, you can save a little money by actually providing your own modem. Just make sure it's one that's supported by your provider. Some of these modems can become a little more complex. Mine's pretty much a simple modem that only provides internet access, but some will include Wi-Fi and switching and other devices all built into a single box. So for a simple user, you've got everything you need in one easy box. Now all the data that's coming out of the cable modem, which is the yellow cable there, goes into this white box here, and this is the router. This is a more simplistic one. There are some more complex routers that have more functionality in them, but this one basically provides an entry point into my network, and that's the yellow cable going from the outside, and the teal colored cable is going back to now all my other network components within the network at home. So the router is designed to manage all the traffic in and out of the network. You're going to have both LAN ports and WAN ports. Those are the two ports on the front there that are consumed by cables. And then you're also going to have inside some security, some things like firewall that allow you to keep people out of your network that don't need to be in there. There's also something called Network Access Translation, or NAT. And what NAT does is it allows everything on your network that has an address to then connect to the internet, and it keeps track of what data belongs to what client. So when information comes back into the network through the network address translation, it's able to send it off into the right location on your home network. Some of the routers may have switches and Wi-Fi and other things like that included also. Now you're looking at a network switch. The switch is what's going to handle multiple wired network devices. multiple switches can be cascaded on the network. So you'll find that this is an 8-port switch, but I could add an additional 8-port or 16-port switch further upstream and just basically connect it with one of these Ethernet cables. Switches come in both managed and unmanaged flavors. An unmanaged switch literally is a couple dollars per port. So you could pick up an 8-port unmanaged switch for $25 to $40, relatively inexpensive. Managed switches are what you would use if you wanted to have more higher end or advanced functions, things like virtual LANs or segmenting or bonding a couple Ethernet channels together. So those are all things that you would do in a managed switch. Now we're looking at the patch panel underneath my desk. When you open up and look inside, you'll actually see that I have a network switch, and that network switch is connected to a patch panel. These cables come from around the house, and they come into this panel. They're all terminated there, and then we use the Ethernet cables to go directly into the switch. Now you'll note that while there is an electrical outlet in this box, there's no electricity going into the router. That's because we're using a technology called Power over Ethernet. The whole idea with Power over Ethernet is that a switch can provide to other devices on the network electricity through the Ethernet interface. So this particular switch does not need an AC adapter because it's receiving its power from the upstream switch. In addition, wireless access points can also use Power over Ethernet, and this allows them to be able to power themselves without having to have an extra AC adapter included. Now that's very convenient if you happen to be mounting one high up on a ceiling or somewhere else where you might not have access to power. Power over Ethernet would allow you to power those devices without actually having to have an outlet next to them. So before we leave the office, I wanted to just show you some of the functions that we actually have running on the network. The first is a server. This is just a simple Mac Mini. This handles all of my network automation. It handles some of the backup, some of the archiving tasks, and generally runs applications that have to be going 24/7. We also have a network attached storage, or NAS device, and this is where I can centralize things like photos, video. I can back up documents to it. All of my archiving of all the client systems happens there, and I can actually access. I can get to this data outside of the office. If I'm out on the road and I need to get a file, I can just literally zap right into it, get what I need. On the right, you'll find an external hard drive, and this is where I will copy data from the NAS onto that hard drive, and then I can swap this off and take it to an offsite location, so I'm ensured that even if the house burns down, I've got a copy of my data. And then over here on the left, we have an uninterruptible power supply. These are really essential. Actually, right now in Austin, we're going through a snowstorm, and a lot of people are out of power. Well, this provides a battery backup of power for all of the functions that you see here while the power is out. So if I lose power, my network will continue to run, and I'll still continue to have internet access for as long as the uninterruptible power supply is running. What you see up on the ceiling is a wireless access point. I've got several of these throughout the house, and these provide Wi-Fi access for all the devices. You can have multiple access points on any network, and that allows you to increase your coverage. I generally recommend one access point for every floor, or one access point for about every 1,000 square feet in the house. Wireless access points can come in a variety of different protocols. These are things like 802.11g or N or AC. You'll hear a lot of those different acronyms, but now the industry is starting to shift over to Wi-Fi 5 or Wi-Fi 6. Those are a little easier for most people to understand. Wi-Fi 5 is equivalent to 802.11ac, and that's most of what the current install base is. Wi-Fi 6 is what most people would recommend for newer deployments. So you generally will find Wi-Fi 5 in most homes today, and if you're going out to buy something now, you may want to invest in Wi-Fi 6 in order to get the latest and greatest technology. Finally, the console is where you manage the entire network and configure all of the devices. This is the main dashboard page where I can look at my connection, I can look at my different devices, I can look at any anomalies, any failures, get everything at a high level view. If I want to drill down into the statistics of what's happening on the network, I can actually take a look at the traffic for different types of applications, different websites, and see where my traffic is going both in and out of the network. I could take a look at a map of the network, and this shows how everything is connected together, how all those different client devices are connected across the network. I can look at all of my network devices, the security gateway, all of the switches, all the Wi-Fi access points, see what their IP addresses are, what their status, experience, uptime is. I can drill down into all of the different clients that we have on the network and see what their experience is, where they're connected, their upstream and downstream activity is, and take a look at uptime for all of those devices. In addition to that, I also have the ability to configure and set up all of my security protocols within the console. So this is a very handy tool for getting a single view into the entire network. For smaller, less complicated products, you typically will have this type of information, but it'll only be for the router. So thanks for watching. I hope you got a good overview of all the different components on a typical home network and understand a little more about what these things do and how they can help you out. Have a great day.